Hi everyone, welcome to another video of Embedded Dragon, my channel. And in this video I want to share with you an interesting thing I got to know just yesterday when a friend of mine was asking me if there is a microcontroller in the market with a gigabit Ethernet capability for his project. So I was searching in the internet and I came across with this interesting website, XMOS, and it seems to be a manufacturer, I don't know, somewhere in China or Hong Kong, if we get to know it. Anyway, and these people, I would say these people are crazy. They're making, with respect of course, they're making microcontrollers with numerous number of cores. So if you take a look into their products, this was exactly what I was looking for. In general solutions, in the silicon, you'll find out that there's a series of microcontrollers referred to as XCore 200. And these awesome microcontrollers have Ethernet, USB, and as you see, general purpose type. So if you go to the Ethernet one, these microcontrollers actually have a lot of cores. You can't imagine. I was always thinking, in microcontrollers, nowadays you have 1, 2, 3 cores, like the tri-core microcontroller of Infineon, but this is just amazing. This can support up to 32 cores. Unbelievable. You have 32, 16, or even less if you need. And the interesting thing is that they work independently. So if we manage to find a datasheet here, for example, for one of these big ones, let's see, go to excuse me, yeah, this one for example. If you download the datasheet, okay, so if you take a look at the internal of this microcontroller, if you download one of the data sheets, you see that its XCore 200 series are actually 32 multi-core microcontrollers, and as you see inside them, for example, in this case, you have something like 12 cores in and if you multiply them by 2, according to what I see here, it's basically 24 cores, and every core is a independent microcontroller CPU with its own amount of memory. So it's like you have many microcontrollers in one chip, and it seems that they have designed this kind of microcontrollers for applications like DSP or digital signal processing or audio application. Also, if you take a look at the website of CMOS, you see they're also working in audio world. So it's all about signal processing and a big amount of processing power. And it's so interesting that this kind of microcontrollers, although they are microcontrollers, they have a performance comparable to a processor. And the company is providing this X-Time Composer Studio, with which you can download it for free, and on the website there's a lot of resources, including the user guides and how to design the hardware and how to write the code and things like this for this. And this X-Time Composer is like the IDE you're going to use with this microcontroller, and it's crazy. You see this, in this type you have 24 real-time cores on a 4 XCore tile, and it's an interesting architecture. Being a RISC, of course, I think many of you know about RISC, reduced instruction set computer, and it can be as efficient as 4,000 million instructions per second in dual issue mode. It means it can issue at the same time, I think, 2 instructions. So in this case it can reach up to 4,000 MIPS. Crazy. 4,000 MIPS. I can't believe it. And so this one also has things like 30 by 32 64-bit MAC instructions for DSP. It has a dual USB 5 fully USB 2 specification, so you have USB, and 176 general purpose GPIO, and a lot more peripherals, like it says 56 1-bit port, 22 4-bit ports, 13 18 ports, and so forth. And also the port sampling rates up to 60 megahertz, and you have 120 channel ends, or it actually, these channels are a method of communicating between program in one core running in one core and program running in another core. So you have 128 channels. So for each tile you have 32 channels for exchanging information, and you have 512 kilobyte internal single cycle SRAM. It's single cycle, I'm not sure, but this is what it claims. And a maximum 128 kilobyte per tile. For code and data storage, 32 kilobyte of internal OTP, or one-time programmable memory for application boot code, if you want, for example, have a secure boot, something like that, and 2 megabytes of internal flash for application code and overlays. So it gives you an enormous amount of memory for a microcontroller, and also processing power. What is very interesting is that, and I don't see it here, but it should be somewhere, about the operating frequency. And I remember in another one that I saw, it was something like 400 or 500 megahertz. So yeah, you see here that these logical cores, each tile has 6 active logical cores, which issue instructions down a shared 5-stage pipeline. So it has a 5-stage pipeline, and instructions from active cores are issued round robin. If up to 5 logical cores are active, each core is allocated a fifth of the processing cycle. If more than 5 cores are active, each core is allocated at least 1 n cycles for n cores. So round robin means when it's a scheduling policy in real-time systems, when you actually give the same amount of time to all the slots. So here, for example, you have 24 cores and all of them are running, so we give them equal amount of time to run their program. And you see that it runs at 500 megahertz. Such a speed is very high for a microcontroller. Like if you think of ESP32 as a SoC, which runs at 240, or new microcontrollers are just the newest ones. I know one from NXP, which I will also talk about in another video, is going to be the first gigahertz microcontroller in the world. But up to now, like the maximum frequency I know about microcontrollers is like, again, from NXP with 600 megahertz. But this is just amazing. The number of cores, even in the NXP one, you don't get many cores like this. And then you can find all the details, and this is just one of them. And actually there are also other ones for less powerful applications, like let's see if we can find one with fewer number of cores. And it's an overview here. We can see this logical cores and all this RGM2, which is like a gigabit Ethernet here given. So yeah, this is the biggest one, I think. So we need to go to the smaller ones to see if there are with less cores. Yeah, so in the XCore USB gigabit Ethernet, you get the biggest number of cores. So this is definitely designed for signal processing and communication applications. So the next one is for the USB. This is the USB, if I'm not mistaken. Yeah. No, this one is the US general purpose, and this one, as you see, again has less cores, 8, 10, 12, 16, 24. So it goes down to 8, and it reaches 1,000 MIPS maybe theoretically. And also in the USB version, or it's the first version. Oh, I think we passed the USB. This is general purpose. This is the gigabit Ethernet, and this is the USB. In the USB, you have from 8 cores and of course up. But I think in the first generation, XS1, you have down to 4 cores, and you can have a power of 400 MIPS, and that's interesting. 4, 6, and again it goes up to 16, 12, and depending on what actually you need. Also in this one you have something like 8 channel 12-bit ADC. You might have something different. In other ones you have to check the data sheet, but I think that's it for now. This company also has some voice solutions which are designed specifically, for silicon. If we open the silicon, okay, it's like this XVF 3510. This one is also very interesting. This is specifically designed for voice recognition and voice processing applications. So there's a voice DSP inside, stereo AEC, and interface canceller and things like this. And we can communicate with I2S as a slave and USB device. You have GPIO, USB, and of course other peripherals. So let's have a look inside this one as well and see about the specifications here, if we can get here. Yeah, so this is what we get. And this one I don't think has many cores, but again it supports 4-channel microphone interface and things like this. So this is specifically designed for audio applications, and it's also very interesting. But I think that the XCore microcontrollers are really great for a variety of projects. Actually, I'm now persuaded and kind of motivated to design a couple of projects using them. So I will have them on my list, and I promise you to have a good design with XCore microcontrollers. Okay, I think that's it for now. Thanks for watching. Don't forget to like and subscribe, and see you next time.